Hello everyone, this is a physical ይህ ፊዚክስ ፕሮብለሞችን የምንሰራበት ቻናላችን ነው። በዚህ ቻናል የምናደርገው ነገር ምንድነው? የፊዚክስ አንዳንድ ፕሮብለሞችን ሴሌክት አድርገን ለተማሪዎች ኤግዛም ሴንተርድ የሆኑ ፕሮብለሞችን መርጠን የምንሰራበት ቻናላችን ነው። ፕሮብለሞችን አብራችሁ በመስራት ሳይድ ባይ ሳይድ የበለጠ የፊዚክስ ላይ ያላችሁን ፕሮብለም የመስራት ስኪል ማዳበር እንድትችሉ ተደርጎ የተዘጋጀ ቪዲዮ ነው። መቀጠል እንችላለን። የምንቀጥለው ፕሮብለም የምናሰራው ከዚህ በኋላ እንዴት ነው የምናደርገው? ፕሮብለሞችን ሲምፕሊ እናስቀምጥና ፕሮብለሞችን ሲምፕሊ ኢንተርፕሬት አድርገን ሶልቭ አድርገን የምንፈልገውን ሪዛልት ማግኘት ነው። Here we have a problem. Simply this problem is mainly on on the oscillation part. So in the oscillation parts, we know that the relation between the frequency and angular frequency and also the maximum speed, energy of oscillation and so on. We'll see in this problem and ሌሎችንም ከዚህ በኋላ ባሉ ፕሮብለሞችም ጨምረ ሌሎችንም ቶፒኮችን እንነካለን ማለት ነው። Of course, here the question says a 0.25 kilogram block attached to a light spring oscillates on a frictionless horizontal table. The oscillation amplitude is 0.125 meter and the block moves at 3 meters per second as pass through equilibrium at x equals to 0. So of course A says find the spring constant K, and B minute calculate the total energy of the block spring system, and finally we will find the block's speed when x equals to A over 2. That's so good. So what we are going to do first is simply illustrate a simple schematic diagram for the problem. Here the problem demands a schematic diagram. So በዚህ አይነት መልኩ illustrate ማድረግ እንችላለን. Here we have a block. Okay, let me go back once again. Okay, here we have a block seated on a frictionless surface and attached to a spring whose spring constant is K, and of course the mass of the block is 0.25 kilogram, and also it says the block moves with to a maximum amplitude of about A equals 0.125 meter. This is ምንድነው? ኦሲሌሽኑ ከጀመረ በኋላ ማክሲመም ሊሄድበት የሚችለው ዲስታንስ ነው from equilibrium point. So the equilibrium point is situated at x equals to 0, of course. So of course from the given information it says the maximum velocity at x equals to 0 is 3 meters per second. That's nice. ከነዚህ given informationዎቻችን ተነስተን የተጠየቁን ጥያቄ ቢኖር A, we will find A says find the spring constant, we will find K, and of course B ላይ we will find the total energy of block spring system, or simply energy total, and also in C we will find the block's speed at x equals to at half of the amplitude. That's so nice. So let's go ahead and simply revise some important points regarding oscillation. So we have seen that for any mass spring system, the angular frequency in which the oscillation occurs, the omega, is simply square root of the spring constant divided by the m. So in fact from this information here we could find the values of K, but also this is one thing we have seen in the relation, between angular frequency and the mass and the spring constant. The maximum velocity of the oscillation is simply the omega the angular frequency times the amplitude of oscillation. So this is our second equation that we have found previously. So ከዚህ ምን እናገኛለን? Now with simple substitution we will find that this implies omega, okay, sorry, once again, the maximum velocity divided by the amplitude is simply square root of k over m. now ያደረኩት ምንድነው equation 2 ወደ equation 1 ነው substitute ያደረኩት። in that case for angular frequency omega substitute ማድረግ ማለት ነው for above to the above equation. So what we are going to next find is simply k. This would be easy. What we will do is simply squaring both sides. We will get v max over a squared times I mass. We will get this is k. Of course, from this result, with direct substitution, one can find the spring constant is simply you have given the maximum velocity from the above 3 meter per second divided by the amplitude. Here you can go to the given information of 0.125 meter, 0.125 meter, and squaring and simply multiplying it simply by mass. Of course, the mass is 0.25 kilogram. In fact, with simple calculation, the spring constant is approximately, you will get not approximately, actually with exact result, you will get 144 Newton per meter. This would be the result we are looking for in part A. So the next part we are asked to find the maximum oscillation energy, or on B where we need to find the Emax or E total energy of oscillation. So since energy is conserved in a simple harmonic motion, we need to remember one thing: the maximum or the total energy is simply the maximum strain energy, which is half k times x maximum squared, or this is simply half times the spring constant times the amplitude squared. So this will be happen under specific condition in which friction is not present in our system. So from the given information we have found the spring constant. It will be easy to find the total energy then. So here 144 Newton per meter times the amplitude is simply from the given information 0.125 meter squared. We would get the total energy of approximately 1.2 decimal place. Could specify the value approximately 1.13 joule of total energy. So that's being said, we go ahead and we will find on part C we are asked to find here the speed of the block at x equals to a over 2. So when the block reaches at half of the amplitude from the equilibrium point, let's say this is the maximum amplitude. So when the block reaches at this point, we need to find here ምን እናያለን? ብሎኩ ፖቴንሻል ኤነርጂ ይኖረዋል። at the same time ደግሞ it will have kinetic energy. So there is an equation that combines both the potential and the kinetic energy. So we don't need detail on proof as well again. So the speed at any point of x, we have proven that the omega times square root of amplitude square minus x square, where x is the point at any point from the equilibrium point. So here, that being said, let me go ahead once forward, and of course here the speed at x equals to a over 2 simply given by omega equals square root of a squared minus a over 2 squared. Now we don't need any calculating angular frequency, since we have seen that the maximum the angular frequency can be expressed in terms of maximum velocity and amplitude. Since let me go once, the maximum velocity is simply omega times a, so we don't need calculating any omegas. It's simply express, we can express using maximum velocity and amplitude. So this is Vmax divided by amplitude square root of a squared minus a squared over 4. So ከዚህ ምን እንመለከታለን? unnecessary የሆኑ ኳንቲቲዎችን መጀመሪያ ላይ ካንስል ማድረግ እንችላለን። Here amplitude is not important here, so here the maximum velocity is given 3 meters per second. So let me simplify once again. Vmax over a, this is actually a into square root of 3 over 4. Simple simplification is the no. Now here we don't need any amplitude term here. So the velocity at x equals to a over 2 will be Vmax times square root of 3 over 4. So with simple direct substitution, we will find that with 3 meters per second times the square root of 3 over 2, 3 over 4, you would get approximately the result of 2.6 meters per second would be the speed at x equals to a over 2. So therefore the velocity would be this thing. So this would be a simple problem related to harmonic motion. በሚቀጥሉት ፕሮብሌሞችም ተመሳሳይ የሆኑ ፕሮብሌሞችን እንመለከታለን። Thank you. Next I will see you next on the next video. Bye bye.